Today we're going to take a look at section 3.7, model using variation. In problem number 1, it says the number of gallons of water W used when taking a shower varies directly as the time T. So when they tell us that it varies directly, your equation is W equals K times T. W represents the water that varies directly as T, the time in minutes. K is that constant of variation. So in our first statement, it says that a shower lasting 5 minutes uses 30 gallons of water. So we're going to use that relationship to help us establish what our constant of variation would be. So we're going to plug in 30 in for W. We're going to try and solve for K, and we know that the time is 5 minutes. So when we solve for K, we get K is 6. So now we can rewrite our direct variation equation using our constant of variation. So we have W equals 6T. Now the question is asking for us to figure out how much water is used in a shower lasting 11 minutes. So since we're trying to figure out the amount of water, we're going to solve for W, and that 11 minutes represents time. So the number of gallons that we would use for 11 minutes would be 66 gallons. In problem number 2, it says the weight of a great white shark varies, that's what we say varies, directly as the cube, as the cube its length. So we would write the weight as W equals direct variation means that we're going to do K, and then the cube of its length should be L to the 3rd power because we are going to cube that. A great white shark caught off Catalina Island, California, was 15 feet long and weighed 2,025 pounds. So this would be our L is 15 and our weight is 2,025. We're going to use this information to help us calculate our constant of variation. 15 cubed comes out to be 3,375. So when we divide both sides by 3,375, K comes out to be 0.6. Now we're going to use that information to rewrite our direct variation equation. The question now asks us to figure out what was the weight of the 20-foot long shark in the novel Jaws. So we have the length, which is 25. We're going to cube that. So now we're going to do 25 cubed and multiply that by 0.6, and the weight of that shark comes out to be 9,375 pounds. In problem number 3, the length of a violin string varies inversely as the frequency of its vibrations. So we will have the length equals K. Now directly means that we multiply, inversely means we're going to divide. So this is going to be K over the frequency. So we'll do F for frequency. A violin string that's 8 inches long, so this is our length, vibrates at a frequency of 640 cycles per second. So our F is 640. Multiply both sides by 640 and we get K is 5,120. Now we can rewrite our equation as L equals 5,120 over F. In this question, they're asking us to figure out what is the frequency of a 10-inch string. So we know that L is 10, and now we need to calculate what F would be. So we're going to multiply both sides by F so we can get rid of the F in the denominator. So we'll have 10F equals 5,120. And then you can now divide both sides by 10. So the frequency would be 512 cycles per second. Go ahead and work on your ticket for today, page 401, problem number 8.